Hello, I'm Edward Tarte, a math teacher. This is another in a series of solution videos to some of my math challenges. The challenge for this video is my handicap foot race challenge. And here's how I presented that challenge in the original video. On the playground, three little girls, Alice, Betty, and Carla, were going to have a foot race under the supervision of an adult who would handicap them according to their ages, their sizes, and their perceived abilities. The adult supervisor positioned Alice at the starting line. She positioned Betty several paces in front of Alice, and she positioned Carla so that Carla had twice as much head start over Betty as Betty had over Alice. Nevertheless, Alice won the race. Alice caught up with Betty after just 3 seconds, and Alice caught up with Carla just 2 seconds after that. Assuming that each of the three girls ran at a constant rate, my question is, how long did it take for Betty to catch up with Carla? Here's my solution. This diagram shows the opening positions of Alice, represented by A, Betty, represented by B, and Carla, represented by C. I designate 15 units of length as the head start given to Betty over Alice, and because Carla had twice as many units of length head start over Betty as Betty had over Alice, from Betty to Carla, we have 30 units of length, making from Alice to Carla a total of 45 units of length. Now I'm going to have little a, little b, and little c stand for the rates of Alice, Betty, and Carla respectively. We are told that Alice caught up with Betty in 3 seconds. I have a diagram where this point represents the place where Alice caught up with Betty, X units away from Betty's starting place. Using the formula distance equals rate times time, we have these two equations. Alice's distance, x plus 15, equals her time, 3 seconds, times her rate A, and Betty's distance, which was only x equals the time, the same time, 3 seconds, times Betty's rate, B. So we have x plus 15 equals 3a, x equals 3b. I subtract this equation from this one, and I get 15 equals 3a minus 3b. I factor out the common factor 3, so I have 15 equals 3 times a minus b. Dividing both sides of that equation by 3 gives me a minus b equals 5. Now we are told that Alice caught up with Carla 2 seconds after that, which would have been 5 seconds after the beginning of the race. I have this point representing the place where Alice caught up with Carla. Alice having started here, Carla having started here. And I called the distance that Carla went from the beginning of the race until Alice caught up with her. I call that distance y. So as we've said, Carla had an initial head start over Alice of 45 units of length. So we have this equation concerning Alice, distance equals rate times time, y plus 45 equals the number of seconds, 5, times Alice's rate A. For Carla, we have just y equals 5 seconds times Carla's rate, c. So we have the two equations y plus 45 equals 5a, y equals 5c. I subtract this second equation from the first one. This is a process similar to what I did up here. I get 45 equals 5 times a minus c. Dividing both sides by 5 gives me a minus c equals 9. I take those two equations, a minus c equals 9, a minus b equals 5. I subtract this equation from this one. When I do that, the b will become positive, the c will stay negative, the a's will subtract to 0, and so I get b minus c equals 4. Now we must focus on Betty catching up with Carla. Carla started with a head start over Betty of 30 units of distance, and I'm calling W the distance from Carla's start to where Betty caught up with Carla. We don't know how long that took for Betty to catch up with Carla. I will call T. Again, using the formula distance equals rate times time, we have for Betty W plus 30 equals Betty's rate B times the time T. And for Carla, we have just the length W equals Carla's rate C times the time T. So we have these two equations. W plus 30 equals B times T. W equals C times T. Subtracting this equation from this one gives me 30 equals T times B minus C. But we found out that B minus C is 4, so I substitute 4 in place of B minus C. I now have 30 equals T times 4. I divide both sides of that equation by 4. I get T equals 30/4, which equals 7.5. And that is our solution. It means it took 7.5 seconds for Betty to catch up with Carla. So that is my solution to my handicap foot race challenge. Thank you for watching this solution video.